Hello everyone, welcome to my YouTube channel. Today I'll be discussing about ResNet architecture. Myself Rohit, studying in Sri Venkateswara College of Engineering. This is for my video assignment. Let's dive in. Introduction to ResNet architecture. Suppose, imagine you're a detective tasked with solving a complicated case involving a series of interconnected events. To crack the case, you decide to gather clues from various sources. But as you delve deeper, you encounter a common problem. Each new clue seems to lead to more confusion rather than clarity. You feel like you are drowning in a sea of information, unable to make sense of it all. This detective scenario mirrors the challenges faced by traditional deep neural network when trying to learn from very deep layers. Just like the detective struggling to maintain clarity as they dive deeper into the case, traditional neural networks encounter difficulties in maintaining useful information flow as they add more layers. This phenomenon is known as vanishing gradient problem. So, to overcome this vanishing gradient problem, we use ResNet. Now, enter ResNet, our superhero in the story. ResNet is like having a seasoned partner by your side, helping you navigate through the complexities of the case with ease. How does ResNet accomplish this? By introducing skip connections. ResNet allows information to flow more freely through the network. Much like how our detective partner help us stay on the track by providing valuable insights, ResNet allows, by skipping connections, to maintain the information to flow more freely through the network. In our detective scenario, ResNet's skip connections act as shortcuts through the network, allowing gradients to bypass certain layers and flow more directly into the input from the input to the output. This prevents the vanishing gradient problem, ensuring that the crucial information isn't lost or diluted as it passes through the network many layers. So moving on, these are the introduction to ResNet architecture. ResNet stands for Residual Neural Network. It was introduced by Microsoft Research in 2015. ResNet is known for its ability to train very deep neural network effectively. So, what is the motivation for residual learning? Traditional deep learning networks suffer from vanishing gradient problem, like I said, giving a detective scenario example. Residual learning aims to address this issue by using shortcut connections, that is, skip connections. These shortcut connections allow the neural networks to learn residual functions directly from input to output sometimes. As you can see in the images illustrated. So, what are the building blocks of ResNet? In essence, ResNet empowers us to tackle complex problems in field like medicine, where the ability to analyze vast amount of data with precise is crucial. So, for something like this to work, the building blocks of ResNet must be complex. This basic building block of ResNet is the residual block. A residual block consists of two convolution layers with a shortcut connection. The output of the shortcut connection is added to the output of the second convolutional layer. So this is the building blocks of ResNet. Stacking residual blocks. ResNet architectures typically stack multiple residual blocks. So the next time you encounter a challenging problem, a deeper ResNet models have hundreds of layers. Stacking residual blocks allows the network to learn complex functions or complex features. So you can have a look at the image here. These are stacking residual blocks. So what are skip connections or shortcut connections? Skip connections in ResNet allows the network to bypass from one or more layers. Skip connections helps with gradient flow and alleviate the vanishing gradient problem. Skip connections enable the training of very deep networks. Residual learning concept. In residual learning, the network learns residual functions instead of directly learning from the desired underlying mapping. This residual function is the difference between the input and the output of a block. This approach simplifies the learning process and improves performance. Now let's dive deeper into our real world scenario. Suppose take an example of medical image analysis. As a doctor, your goal is to accurately diagnose patients based on their medical images such as X-ray, CT scans, and MRI scans. However, medical images are incredibly complex, often containing subtle patterns or anomalies that are challenging to detect, especially in the presence of noise or variations in images or image qualities. Here's where ResNet steps in as your indispensable ally. Imagine you are analyzing an MRI scan of a patient's brain to detect the presence of tumor. The MRI scan provides a detailed view of the brain and its internal structures, but distinguish between normal tissue and abnormal growths requires a keen eye and advanced analytical tools. In this scenario, ResNet's ability to maintain information and information flow is very deep. Sorry. In this scenario, ResNet's ability to maintain information flow in very deep networks is invaluable. As you feed the MRI scan into the ResNet based model, each layer of the networks acts as a filter, extracting increasingly abstract features from the images. However, without mechanisms to address the vanishing gradient problem, deeper layers may struggle to learn meaningful representations, leading to diminished performance in detecting tumors or the other abnormalities. Here's where ResNet revolutionary design comes into play. By introducing skip connections that enable shortcut through the networks, ResNet ensures that the gradients can flow freely and information isn't lost as it traverses through the layers. This allows the network to effectively capture both low-level details and high-level abstract features, enhancing its ability to discriminate between normal and abnormal tissue in the MRI scan. As the ResNet based model processes the MRI scan, it's akin to having a accept or an expert radiologist examine the image layer by layer, highlighting regions of interest and flagging potential abnormalities for future investigation. This ability to maintain information flow and preserve crucial details ensure that every subtle signs of tumors are detected with high accuracy, enabling early diagnosis and timely intervention for the patient. In the realm of medical image analysis, where the stakes are high and every detail matters, ResNet's resilience against the vanishing gradient problem and its capacity to learn complex representations are game changers. By leveraging ResNet's power, doctors and researchers can unlock new insights from medical images, paving the way for improved diagnostics, personalized treatment strategies, and better patient outcomes. In conclusion, the partnership between doctors and ResNet exemplifies the synergy between human expertise and AI driven technologies. By combining the strengths of both, we can tackle some of the most pressing challenging pressing challenges in healthcare and usher in a new era of precision medicine, where every patient receives the care and attention they deserve. So moving on, types of ResNet architectures. ResNet architecture comes in different depths such as ResNet 18, ResNet 50, ResNet 101 and ResNet 152. Deeper ResNet models tend to have better performance but require more computational resources. The choice of ResNet architecture depends on specific tasks and datasets. Training ResNet models. Training ResNet models requires a large datasets, significant computational resources. Techniques such as data augmentation, batch normalization, and learning rate scheduling are commonly used. Pre-trained RS models are available for transfer learning on new datasets. Applications. So when it comes to applications, one of the applications I just discussed was medical image analysis. So where image classification is the biggest advantage, object detection, and transfer learning. Pre-trained ResNet models trained on large-scale datasets like ImageNet are commonly used to feature extractors for transfer learning. By fine-tuning these models on a smaller domain-specific datasets, one can achieve good performance even with limited labeled data. So conclusion, ResNet architectures has revolutionary deep learning by enabling the training of very deep neural network. The use of skip connections and residual learning has proven to be effective in improving gradient flow